Building a machine learning model is always easy. What's difficult is to build a real life project. That means when a normal user is using it, they should see a good accuracy on it. They should not see lot of hallucination, lot of errors. That's a tough job. It's very easy when you have a training set, when you have a data set to achieve a 99% accuracy, but you often see that it fails when it goes to prod. In this video, we will discuss why that happens, what are the issues which we can fix in ML, and how to identify what could be the reason they are not working in prod. All these things we'll covering as part of this video. So let's start. In normally, whenever a model is not working in production, they are mainly, or anywhere, even in training set, there are mostly two challenges. The first challenge would be data challenge. And second would be model challenge. Data challenge corresponds to issues related with data. That what can you do about it? Whether it is something which you can fix or not fix with respect to data, rather than running hundreds of models altogether. There are many engineers who keep on running different models again and again and again to see what could be the issue. But sometimes the issue is in data itself. So you have to verify that first before moving to model phase. Then there is model challenges. Sometimes you will pick a model which is not efficient on production set but will work great on training set, and vice versa. So we'll cover both of these in detail. So when it comes to data challenge, the one of the most common is insufficient data. So what do you understand by insufficient data? For example, let's say you have a toddler in your home. So what do? You tell them, okay, this is a cat. Okay. When you show them another image, there are high probability chances that they will also call it a cat. Why? Because you have not taught that toddler enough that what cat actually represents. Only if you show them 4 to 5 images of this cat, only then they will be able to identify what cat actually is. And then they will be able to detect, right? In same way, in ML also, if you give them just 50 images, ML might not be able to identify that what a cat looks like. Maybe it need 5,000, 50,000, 5 million or something like that images just to know what actual cat is. Just to get a complete idea so that it has a good accuracy. But there are many times when people believe that insufficient data is the only problem. That means if your model is not working, let's bring in more data. Let's waste more time and bring in more data. But there are often cases where insufficient data is not the problem. There are also other use cases as well. So let's cover them also. So one is non-representative data. What do you understand by non-representative data? It means that, let's go with an example. Let's say there's a teacher who took an exam, and just to get an overall idea of the class strength, they asked the top scorers that was that exam easy. They asked the top scorer that was that exam easy. And the top scorer will obviously say that, okay, the exam was easy because they all got A plus. But that's not the average consensus, right? You have to ask the entire class to know that what is the average result, whether the exam was actually hard or not hard. This is sampling bias. That means you're not considering the overall data which you want to evaluate with, right? A ML level example is that suppose you are given a cat image. Okay, let's say you are given a cat image, sometimes face, something like this, and it has two legs. Pardon my drawing. It has two legs, something like this, and you are able to, you want to find whether this is a cat or not a cat. Okay, but the thing is, you're using this in the production. Your user uploaded this to find whether it's a cat or not cat, but you have trained your ML model only on the faces of the cat. You have not trained it on anywhere else. So although your ML model knows that, okay, this face belongs to cat, they doesn't know whether this body belongs to cat or not cat. So whenever we have a data, whenever we want to launch a product in production, the main thing is that does the data match what the real world use case is, what the actual consumer wants to upload, wants to use? Does it match that? Only then it is beneficial, right? Sampling bias is this only. Sampling bias says that whenever when you are collecting the data, you're not considering the overall scenarios. Let's take one more example. For example, let's say that you want to build housing prices in a particular area. Let's say this is a map of some area and you want to predict housing prices there. Now let's say it's divided into three sections: M1, M2, M3. And M2 belongs to like rich area or the posh area where the most prices are above 100k. And M3 belongs to, let's say, slums where the housing prices are like about 1k to 5k. And let's say it is also around 10k to 50k. Now let's say you are building a housing price modulator for this particular area and you want to find out that what actual price is. Well, let's say your actual data set only comprises of M2 data and you have no idea about M1, M3. Now, do you think that it will actually be able to predict the results of M1 and M3? No, right? Because your data set only trains it on M2, where the houses are all in posh area, all are above 100k. So no matter what ML model tries to do, it will never be able to predict the housing prices for M3 and M1. This is sampling bias. So whenever you want to create an ML model, first ask yourself that who are the actual users, who are the actual consumers, how will they use it, how will they upload it. That's the first question which should come to your mind. Another example could be, let's say, self-driving car. Someone did a training data set on a California road and cars are working very fine. But as soon as they launched it in a snowy area, the system failed. Why? Because it was never trained there. So this is the example of non-representing data or sampling bias. Let's move to next. Poor quality data. What does that mean? Since most of the data is collected by humans, there could be high chances that there are some errors inside them. Some values could be null, some values could be empty, some values could be incorrect as well. For example, there is no way that there could be a housing price, that there could be a housing price of $5, right? That means someone made a mistake in collecting this data, and this is an outlier. Same way you have null and this also. But why is that an issue? Why does that cause a problem? If you have like 100,000 of data, let's say 1% data is like that. So will that actually impact the ML model? Let's think of it as an example. Let's say you are a teacher. Okay, you are a teacher and you have a sheet of some students' answer, right? So this is an answer sheet. And you drop something on it, let's say, and one of the question answer got erased. Now what will you do? Will you mark them 0? Will you give them full marks? Will you give them average out of all the answers they got? How will you decide? Based on what you give it to them, their total score might change from like 80 to 85 if it's 5 marks question, right? Sometimes it can also affect the pass fail scenario. Let's say someone got 28, this was 5 marks question and they got it right, so they could have gotten 33 and would have passed. But since you made a mistake, now you don't know what to give. That's what happens in ML. Sometimes these outliers cause an issue in ML model. ML model is not able to find out that what to do with it. Since there are some exceptions, there could be more exceptions also according to ML. So we have to handle all these null cases scenarios, empty values and outliers. We have to come up with a way to resolve them. Maybe we can remove the entire rows so that ML doesn't have to care with it. Maybe we can remove this entire row so that ML doesn't have to worry. Or let's say that we took an average of the remaining values and fill this value with an average. Maybe we could do that. It's not a generic answer which I can tell you right now and you apply it to all models. You have to think that based on each and every scenario what to do. For example, let's say that if there was a housing prices in a particular area with a particular pin code, I might took an average over the remaining numbers and apply them. Let's say there are 10,000 rows data set and only 10 rows are there which have outliers. I can directly remove them because it won't impact that much on data set, right? But we have to do something based on our use case. So that is how you handle poor quality data. Now, another concept in data handling itself is feature engineering. Feature engineering is you are trying to identify that what features are best for our ML use case. For example, let's say there's a housing price prediction, right? Now, for housing price, does a owner favorite color matters? No matter whether your favorite color is blue, red, or green, it won't affect the housing price, right? So why to confuse your ML model in trying to find relation between this and housing price? It's much better if you can just skip it altogether, right? Second one is street name. When you already have a pin code, and let's say in generic scenario, let's assume hypothetically that for a particular zip code, the housing prices are mostly relevant. Then you don't need a street name because it's not like if you have two streets close by, one of them would be expensive, one of them would be cheaper. In most scenarios, they would have the same price. So this is also irrelevant data, which you can ignore to make your ML model much concise in processing, more proficient in finding a accurate result. Let's take another example of this as well. Sometimes there could also be a scenario that in housing price, like same as above example, you have like length and width of the house. Okay. And you have a price also given for an house. But when you try to find a correlation between them, you are finding that there is a very low correlation between length, width, and price. Maybe if you combine them, maybe if you multiply them and get another feature size, you are able to find high correlation between size and price. So you combine both of these features to make a common one to find a more relation with an output to give a better ML accuracy. So this is also feature extraction. That means you're creating new features based on your existing features, right? This is also known as dimensionality reduction. Basically, you can think of it like that, that each column represents a dimension, whether it's a length, width, area, pin code, and what else. Everything is rating a dimension. And when you're decreasing it, that's known as dimensional reduction. That is all for today class. Next class, we'll discuss about the challenges with respect to model, where we need better features into that, whether we need a more powerful model or not, and whether there is an overfitting, underfitting, how to test whether model works or not works. All these things we'll cover in the next class. Thank you. Bye.